It's CCNA 200-301 Day 6, and it's wireless virtualization and switching fundamentals. So, let's get into it. Let's begin with verifying IP parameters. To verify IP parameters such as IP address, subnet mask, default gateway, and DNS servers on different client operating systems, you can use various built-in tools and commands. Below are the steps for Windows, macOS, and So there's Windows, where you use command prompt, which is the app on Windows that just comes pre-built in a computer. You open it, and you enter in ipconfig/all. That will give you everything you need to know. Then with Mac, you open it up and you put in ifconfig. You put that in, and you'll get all your IP parameters. Next up is wireless principles. We're going to cover these wireless principles. Let's go. So, start off with non-overlapping Wi-Fi channels. Non-overlapping Wi-Fi channels refer to the channels in the Wi-Fi spectrum that do not interfere with each other, ensuring better performance and less interference. This is particularly important in the 2.4 GHz and 5 GHz frequency bands. 2.4 GHz band, the 2.4 GHz band has 14 channels, which depends on the region, but each 22 megahertz wide, but only 3 or 4 in some regions of the channels are not overlapping. You need to remember these numbers for the CCNA, which is channels 1, 6, and 11, which are commonly used in the US and other regions. You will probably see a question that's like, which of these channels are compatible? And it'll be like 3, 2, and 1, or like 1, 2, and 5. And if you see 1, 6, and 11, that's the key number that should be over on the wireless, like Wi-Fi non-overlapping channels. Channel 14 is used in Japan and can be considered non-overlapping, and using it reduces interference and improves performance. The 5 GHz band has more available channels, each 20 megahertz wide, and can support more non-overlapping channels. There are up to 24 non-overlapping channels in the 5 GHz band, and with the use of channels with higher frequencies, this provides more bandwidth and reduced interference. SSID. The SSID, or Service Set Identifier, is the name assigned to a Wi-Fi network, allowing devices to identify and connect to it. It is essentially the network's name that appears in the list of available networks on a device. The broadcast SSID, by default, it's Wi-Fi networks broadcast their SSID to make them visible to nearby devices. This allows users to easily find and connect to the network. Think of these as like, say you're at a new person's house, and then you're like, hey, what's your Wi-Fi? And then you open up settings and you'll see like a bunch of Wi-Fis. That's broadcast SSIDs, that each of those routers in that area is broadcasting, and then you choose the one of that and then you put in the password. Hidden SSIDs are where some networks disable the SSID broadcast, and then they'll have you manually enter it. SSID naming. SSIDs can be up to 32 characters long and include letters, numbers, and special characters. Radio frequency, or RF, refers to the electromagnetic wave frequencies used for wireless communication. So in the context of Wi-Fi, it's used to transmit data between devices. There's frequency bands, which will be covered, where there's Wi-Fi operates in the 2.4 GHz and 5 GHz frequency bands. The 2.4 GHz band is longer range, better penetration through obstacles, but it's more prone to interference. 5 GHz band is shorter range, less interference, and higher data rates. Channel is RF spectrum is divided into channels that can be used for communication. Proper channel selection is important to avoid interference. Signal strength and quality, measured in dBm, decibels relative to a milliwatt, stronger signals provide better performance. So that's what signal strength is measured in dBm, but I don't think you'll need that for the CCNA. It's just extra information. And then quality, it's better, right? So, and interference, other devices like microwaves, cordless phones can cause RF interference, impacting Wi-Fi performance. So that's mainly on 2.4 gigahertz. So yeah, because those transmit 2.4 gigahertz waves. Encryption is what it would be in Wi-Fi. Let's ask. So encryption in Wi-Fi is the process of converting data into a secure format that cannot easily be read by unauthorized users. It is a critical aspect of securing wireless networks. Common Wi-Fi encryption standards are WEP, which is Wired Equivalent Privacy, which is an older and less secure encryption method. It is vulnerable to various attacks and not recommended for use. WPA, which is Wi-Fi Protected Access. You need to know all these, by the way, like make sure you're taking notes or something. Oh, 1 second. Yeah. Wi-Fi Protected Access, which is an improvement over WEP, offering better security. Wi-Fi Personal, which is Wi-Fi Personal or Wi-Fi Protected Access Password Shared Key, which uses a pre-shared key password. WPA Enterprise uses a radius server. We'll cover what a radius server is in a later episode, but just know it's a server that's used for authentication. Then WPA2 is an enhanced version of WPA, widely used for its strong security. WPA2 Personal, and it uses a pre-shared key. And there's also more, which is WPA2, which is Enterprise. It's just that, but it's better because WPA2 is better, and it uses a radius server. WPA3, which is the latest standard providing improved security over WPA2. WPA3 Personal, which uses a simultaneous authentication of equals for a better password security. And WPA3 Enterprise offers stronger encryption and security features for enterprise environments. Importance of encryption. Data protection. So, encryption protects your data, and it encrypts the data transmitted over the network, protecting it from eavesdroppers. It has authentication, which ensures that only authorized users can connect to the network. It has integrity, which protects the data from being altered during transmission. And by understanding these wireless principles, you can effectively manage and secure Wi-Fi networks, ensuring optimal performance and security. Virtualization. Virtualization is a technology that allows multiple virtual instances to run on a single physical hardware system. This is achieved by abstracting hardware resources and creating virtual versions of them. Below are the fundamentals of virtualization, focusing on server virtualization, containers, and VRFs, which is virtual, routing, and forwarding. So, there are many types of virtualization that we'll be going through in the next slides. So let's go along. Server virtualization. So server virtualization, you need to know virtualization. It's a very cool topic. It's about basically where you virtualize a component of a computer. So this created mega shifts inside like data centers and stuff. But let's continue. Server virtualization involves partitioning a physical server into multiple virtual servers, each running its own operating system and applications. So it takes one server's computing parts and splits it into like fake virtual servers with their own OS and applications. This is achieved using a hypervisor, which you need to know. And this manages the hardware and allocates resources to each VM or virtual machine. Key components are these. The hypervisor in a server virtualization, these are the key components, which is the hypervisor, which is a software layer that enables multiple VMs to run on a single physical server. There are two types of hypervisors. It's the type 1, bare metal, which runs directly on the physical interface or physical hardware. An example would be like VMware, ESXi. If you have experience with IT, you'll know what these are. Then type 2 is hosted, which runs on a host operating system. And this is also done through like VMware Workstation, Oracle, VirtualBox, things like that. A VM is an isolated environment that acts like a physical computer. Each VM has its own operating system and applications. Virtual resources includes virtual CPUs, memory, storage, and network interfaces associated to each VM. Benefits of server virtualization: resource utilization, isolation, scalability, and cost efficiency. So it uses the hardware better. Each VM operates on its own. It's scalable. You can delete, create, and modify them. And then also it's improved energy efficiency. Containers are a lightweight form of virtualization that package an application and its dependencies into a single executable unit. So unlike VMs, containers share the host operating system kernel but are isolated from each other. Key components are the container engine, container image, and container. So the container engine is the software that manages the containers. Image is a lightweight standalone package that includes everything needed to run on an application. And then a container is an instance of a container image running on the host system. Benefits: efficiency. Containers are more lightweight and faster compared to VMs. It's consistency, portability, and scalability. So it's portable, consistent, right? And applicants run consistently. It's scalable because you can expand. Virtual routing and forwarding, VRF, allows multiple instances of a routing table to coexist on the same router, effectively creating multiple virtual routers within a single physical router. Each VRF operates independently, maintaining its own routes and policies. The key components of this is VRF instances, which separate routing tables that isolate traffic within each instant, route distinguishers, which are unique identifiers used to distinguish between routes in different VRFs, and route targets, which attribute for use for import and export policies between VRFs. The benefits are isolation, security, and efficiency. So a summary of that stuff. Let's look at this chart I made for you. Virtualization type, serverless containers, VRF, and then this is like their key components and benefits. Switching. Switching is a fundamental concept in networking that involves directing data frames within a local area network based on MAC addresses. Here are the key switching concepts explained. So let's cover them in the next slides. MAC learning and aging. MAC learning is a process by which a network switch discovers the MAC addresses of devices connected to its own ports. When a frame arrives on a switch port, the switch examines the source MAC address and associates it with the port in the MAC address table. MAC aging refers to the process by which entries in the MAC address table are removed after a certain period of inactivity. This is done to ensure that the table remains up to date and does not become filled with obsolete information. Let's go over the process of this. So the process, MAC learning. So the frame arrives at the switch on a specific port. The switch inspects the source MAC address of the frame and it uploads it to its MAC address table to map the source MAC address. MAC aging is when each entry in the MAC address table has a timer associated with it. If no frames are retrieved from that MAC address, it will just get removed after the timer expires, and then the switch can accommodate new devices. Frame switching is the process of which a switch forwards a data frame from one point to another based on the destination MAC address. Process would be frame reception, and then it goes to frame forwarding. So frame reception, it receives a frame, does a MAC address lookup, it searches up where it's supposed to go, and then it forwards it to there. And if it's not found, it floods it all to floods the frame to all ports except the one that was retrieved. Remember this is usually a question, if I'm being honest. You see it everywhere. If you're taking like a class or something, this is a question. It floods it to the frame to all ports except the one that was received. Frame flooding, like we just talked about. Frame flooding occurs when the switch forwards a frame out of all ports except the one on which it was received. Because the destination MAC address is not in the MAC address table, this is typically done for broadcast, multicast, and unknown unicast frames. So this is broadcast flooding, multicast flooding, and unknown unicast flooding. The frame is sent to all devices in a broadcast domain. The frame is sent to all devices subscribed in a particular multicast group, and then their frame is sent to all ports where the switch does not have an entry for the destination MAC address in its table. MAC address table, also known as content addressable memory or CAM table, is a database used by a switch to store mapping between MAC addresses and switched ports. This table allows the switch to more efficiently forward frames to the correct destination port. A tip from me is MAC address table, they might try confusing you by calling it a CAM table, but it's interchangeable and they're the same thing. The structure, entries, is each entry maps a MAC address to a specific port, and then there's the aging timer that we talked about, where it just removes the stale entries that don't get used again. And then MAC address table uses is like usage of forwarding frames. The switch uses the table to determine the correct port for forwarding frames based on the destination MAC address. Learning MAC addresses, the switch dynamically updates the table by learning MAC addresses from incoming frames. And then maintaining efficiency by aging out old entries, and the switch ensures that the table remains relevant and efficient. So that's the summary if you want to read on that or take notes. Alright, let's get to our practice questions. What does a CAM table do? A, B, C, or D? I'll let you pause and you pick the answer. The answer is B. This is why. Remember, CAM tables are interchangeable with MAC address tables. They might trick you on the CCNA. So remember, it's just the same thing. Part 2. What statement on WPA3 is true? A, B, or C? C is the answer because it's the latest and improves security. Reason to be, it's WPA3, which is the newest. Just look at the 3 and figure it's the latest standard, and that will answer your question for you. Simple. Practice question 3. How do you verify an IP address on Windows? You need to know this part too. A or B? Answer is B. Remember, Windows has this where you need IP config. So remember that. Thanks for watching. Hope you like this show or series. If you want to support this series, like, comment, and subscribe. And a link to my Patreon is in the description below if you want to drop a donation of appreciation for this course. But it's all free and I don't expect anything from you guys. I hope you're benefiting. Thanks for watching and see you.